Hey folks, welcome back to our next Algebra 2 lesson. We're going to be talking about the first lesson in Chapter 3, which is simplifying radicals. So I know that you've seen simplifying radicals such as square roots and cube roots in the past. I'm not trying to say you don't know them. But we're going to throw in a few other things, some key vocabulary, and look at it through a slightly different lens. Let's take a look. So we're going to start off with square roots and then expand from there. I know that you've seen this before. We're just going to go a bit more in depth, maybe talk about a few vocab words which you have not seen before, then work with it. So a square root of some number k, that's what this is standing for, is one of the two equal factors whose product is k. And remember when we're talking about the two equal factors and the product, talking about multiplication with this. So if we have x squared equals 36, well, two numbers that are the same and multiply to 36 are 6. So we can say x equals 6. Now, there is another solution, though. We know that x is equal to 6, but it's also equal to negative 6. And we can rewrite it like this. X equals plus or minus 6. That way, anyone looking at our work knows this does have two solutions. If you're wondering, wait, where the heck did that negative 6 come from? Well, you can do 6 times 6, and that equals 36. You can do negative 6 times negative 6. Well, the two 6's become 36, and the two negatives cancel out. We have something similar over here with the a squared equals 25, with our second one. Well, that means that a is going to equal also plus or minus 5, because positive 5 times positive 5 is equal to positive 25, but also negative 5 times negative 5 is equal to positive 25. That brings us to this idea of the principal square root. So the principal square root of a positive number is the positive square root. So the principal square root of 9 is 3. Principal square root of 5 is radical 5, or square root of 5. So in general, when we refer to the square of a number, we mean the principal square root. Now, if you were asked to find all solutions, these are all solutions to the equation x squared equals 36. And these are all the solutions to the equation a squared equals 25. It depends on if we're saying the real number or all solutions. So cube root, something else that you've seen before, I know it. Cube root of k, again, k here is meaning some number, k, is one of the three equal factors whose product is k. And again, three equal factors whose product is k. We're talking about multiplication here still. So if I have x to the third, well, that means that x is equal to 2. And I can do a check, 2 times 2 times 2, well, that's just equal to 8. Over here, I can do a check. If b to the third power is 27, well, that means that b is equal to 3. And I can do a check, 3 times 3 times 3 is going to be 27. Now here, there's only one real number that is the cube root of 125. And that cube root of 125 is going to just be called 5. Because 5 to the third power is equal to 125. This real number is called the principal cube root. So I can say that 2 is the principal cube root of 8. I can say that 3 is the principal cube root of 27. Now there are other roots, and we're going to see later with something called the fundamental theorem of algebra that if I have an equation with something to the third power, there are 3 solutions. And there are 3 solutions to this equation, x equals 8. Only one of them is a real number. The other two are what we call complex numbers, which we'll talk about later. Now, the nth root. So, the nth root of k, still a number, is one of the n equal factors whose product is k. And you might be saying, but n isn't a number. How can we have equal factors of it? Well, even though n isn't a number, it can mean any number. So, if we have the 7th root, that means there are 7 equal factors whose product is k. If I'm trying to find the 10th root, that means there are 10 equal factors whose product is k. And a bit of vocab as we're talking about it. The radical is this entire thing. I refer to this entire thing as the radical. Typically, if I say radical 5, I mean the square root of 5. That's how I would say it out loud. If I was talking about the cube root of 5, I would no longer just say radical 5, I would say cubed root of 5. Now, whatever this number outside is, that's called the index, and that's telling us how many equal factors we're having of that number. So in this example, right here, I want 4 equal factors who all come out to the product of 16. Last but not least, the radicand. That's everything under here. Everything underneath the radical sign is our radicand. And remember, you can't do it. All right. So we're going to evaluate each one of these in the set of real numbers. Now, a note about this. Most numbers that you've dealt with in your entire academic career are what we call real numbers. That includes every whole number, includes every integer, includes zero, includes positive, includes negatives, includes fractions, includes decimals that end, includes decimals that doesn't end, includes irrational numbers. However, what we don't consider a real number is a radical underneath, a negative underneath a radical sign. For instance, this is not a real number. There are no two numbers that multiply together to be -1. It won't work. So, not a real number. And let's take a look at these. We're going to simplify each one. And even though we're in the set of real numbers, we're going to list down every single solution that we can possibly think of. So let's do A here. This will be A. Well, what's the square root of 25? Well, the square root of 25 is just equal to positive or -5. That's it. There are two solutions. It doesn't matter that one is negative and one is positive. They're both real numbers. Let's talk about B. Now, what gets a lot of people with questions like B is they say, well, wait a second, you just had a negative under a square root. Now you have a negative and a square root. What gives? You said that couldn't be possible. Well, here, because the negative is outside the square root, it's totally possible. It's not underneath the square root. So, I just need to break down my 81 and my x. And here's a great way of doing it. I'm going to take my factors of 81. Well, that's 9 and 9, which splits into 3 and 3. I'm also going to take my factors of x and list them out. But I just know x to the 6 is equal to 1, 2, 3, 4, 5, 6. So that means that my negative square root of 81x to the 6th is just equal to negative. You're going to see why that's such a long radical sign in a second. 3 times 3 times 3 times 3. That's coming from these. Times 1, 2, 3, 4, 5, 6. And I'm going to look for groups the size of the index. Right here, there's no index. There's no number right here. So that tells me this is a square root. My index is 2. I'm looking for two numbers that are going to multiply together. So I got a pair of two numbers here. I got a pair of two numbers here. Got a pair of two numbers here. Got a pair of two numbers here. And I have a pair of two numbers here. Now, because the square root are looking for the same number, each one of these green circles is going to send one of their number outside the radical. Which means I'm going to bring down my negative, and then I'm going to bring down 3 from this, times 3 from this, times x from this, times x from this, times x from this. Now, you'll notice that I'm left with nothing under my radical. That's perfectly all right. That happens. We didn't have anything left under the radical for our first example here. If you have nothing left on the radical, you just don't write the radical. Last step, I'm just going to simplify everything together. Well, the negative, 3 times 3 is 9, and I have 3 x's, so x to the 3rd power. And this would be my simplified form. Totally works. So, let's take a look at the next one, at C. So for C, I have the square root of, the cube root of 1 over 27. Because my index here is 3, I can do a very similar method to what I did in the previous one, except instead of looking for groups of 2, I'm going to look for groups of 3. So this is just equal to 1 and 3 times 3 times 3. Now, we know what the cube root of 1 is. Technically, I can make this 1 times 1 times 1. So I got a group of 3. I have a second group of 3, which means my numerator comes out, my denominator comes out, and I have nothing left under this radical, so I can just get rid of it. You'll notice that here, I intentionally did not put a plus or minus sign. There's no plus or minus sign here. It just implies that this is just positive. And that's because this is a cubed root. Oh, excuse me. That should have a cube in it as well. All right. Let's take a look at the last one, at D. The fourth root of negative 16. Now, here's where we run into a bit of annoyance. This doesn't have an answer. There is no number that can multiply by itself 4 times, and we know it has to be 4 because of this index of 4, to equal negative 16. Because of that, this has no real solutions. There is a solution, but it's not a real number. So we're not going to worry about it right now because we were just asked to find all of them in the set of real numbers. This one has no real solution. No real number makes it true, so we're done. So you've seen how to simplify square roots, cube roots, fourth roots. You know that the index just tells you how many numbers of the same kind that you need. You're going to go to Delta Math now and give it a shot. So complete those Delta Math problems, complete the summary, and then read the next section and complete that reading check. All right, folks, have a good one, stay safe, and I'll talk at you soon.